All right, let's look at this problem here, and we're going to use linear regression to predict a future value. And so the thing that we have to do is we're going to have to set up our calculator to calculate our linear regression lines for us. So we're going to have to get the data back, data into our lists. So I'm going to show this for the TI 84, and then I will have a video posted for the TI 30 on a generic list. Well, let's get over to our TI 84. Now, one of the things on the TI 84 that you need to do is you need to go to catalog and go all the way down to diagnostics on. And this will help it show R values. In general, it doesn't display the R value, which is the correlation coefficient, unless you have diagnostics on. So I'll turn diagnostics on, and I'll come into my stats, and I want to edit the lists. And what I'm going to do here is I'm going to use list 1 for my X values and list 2 for my Y values. So if we look at what we have here, my Y values are going to be 0, 2, 4, 6, and 8. We're counting by 2s, but each 2 represents 20 years. So our X value is counting by 10s, right? Because 1 would have been 1910, 3 would have been 1930, and so on. So it counts by 10s. So what we want to do over here is we want to come back to our calculator, and we want to make sure that we enter in the calculator 0 for the first X value, 2 for the second X value, 4 for the third X value, 6, and 8. And so we have our X values. I'm going to come over to list 2, and we're going to put our Y values in list 2. But we've got to line them up with our data. So where list 1 has 0, list 2 should have 49.8. And so these should line up across our lists. So let's go back to our calculator here and make sure that we're lining up. So 0 has a Y, X value of 0 has a Y value of 49.8, 52.1, 53.7, 54.9, and 55.9. And so now I have a paired list of X values and Y values. So I can come to my stat function, and I can come to calculate, and I'm going to do a linear regression. And it's going to give me a variable for the slope and a variable for the y-intercept. So I'll hit enter on this. List 1 is my X value, list 2 is my Y value. So I'll calculate. And I get 0.75 for A and 50.28 for B. And then my correlation coefficient is 0.985. That means there's strong correlation here, right? If you remember on the PDF I sent out with an example of how to do this in Excel, we looked at the correlation values, or the R values, and how spread our data was. So let's bring this back here and use this to predict future values. So what I have here, oops, I left some of this up. Let me just, I was writing this down here, but what I want to do is this calculation here. That was a scratch thought I had earlier while I was working this out. So we can write the linear equation that comes out of the calculator as y equals 0.75x plus 50.28. So we can think of this as a function where if I put in some value of x, I'm going to get my life expectancy as the output. And since it's fairly linear, the correlation coefficient, or R, is equal to 0.9855. The linear, any future value is going to be very close to this line. And so this becomes a good predictor of future values. So what I want to find is the year 2020. And remember, the X values are counting by tens. And we were looking at the year 1900. So That's 120 years, but because we were counting by tens, we're looking for when x was 12. So I'm going to make a function of 12, which means 0.75 times 12 plus 50.28. Well, I'll come back here to the calculator, and let's see, 0.75, whoops, not displaying the calculator, sorry about that, 0.75 times 12 plus 50.28. And so we are looking at a life expectancy of 59.28, if I think we go from what this asked. All right, yeah, life expectancy would go to 59.28. And so, whoops. That's the prediction we can make based off of the strong correlation, because the correlation coefficient is close to an absolute value of 1. Right? And this says it's an increasing linear function. If this was a negative 0.98, it would be decreasing. But life expectancy is going up.